This is the video for 4.7. The title of the section is Introduction to Coordinate Proof, and we did a little tiny coordinate proof last section where we had to do side, side, side. So we had to do the distance formula 3 times to find the sides. And so when we did that, we defined what coordinate geometry was. So a coordinate proof is a proof that uses coordinate geometry. And you'll see tomorrow when we do a coordinate proof in the lesson that it's not really a typical like 2-column proof. It's a little different. Today we're just going to practice setting them up, and then tomorrow we'll actually do one. Alright, the first step of a coordinate proof is to position the figure in the plane. Now, you have on your vocabulary grid the positioning list. All it's saying is, oh, that's weird. All it's saying is if you take some time to put the figure in a place where it's easy to work with, then you'll have an easier time doing your proof later on. So I can put this figure, say it's a triangle, anywhere I want to, but using one of these 4 strategies is going to make my life easier. So here are your strategies. Use the origin as a vertex and keep the figure in quadrant 1. What that does is that keeps all your vertices positive numbers, and so you don't have to worry about dealing with negatives. The other one is to center the figure at the origin. One is to center a side of the figure at the origin. And the last one is to use one or both axes as sides of the figure. Now the one that we use the most is actually the first and the last combined together if possible. So use one or both axes as the sides and keep it in quadrant 1. So here's some of the things I mean by those. So like with that one, when I was talking about using both of those together, if we have a rectangle, we can make our rectangle like this. So the origin is one of my vertices, and the 2 axes, the y and the x-axis, are 2 of the sides. Then that keeps everything in quadrant 1, and it keeps everything vertical and horizontal, so I can just count rather than having to do the distance formula. The number 2 says center the figure at the origin. So if we had a square, I might do something like this and keep it centered at the origin, and that might make things easier for me depending on what I'm trying to prove. And number 3 says center a side of the figure at the origin. So that would be like this. And if I was trying to prove something like midpoint, then this might be easier because I have the 2 sides there. Okay, so let's go practice. Position a square with the side lengths of 6 in the coordinate plane and label your vertices. So you can use any of the methods you want. I told you the most common method is to put one of the vertices at the origin and then to keep everything in quadrant 1. So if you did that, then this would be 6, 0. And this would be 0, 6. And this point would be 6, 6. So this would be the most common way to do that, but you could also do 1, 2, 3. You could also do like this. Oh, I didn't go far enough down. How about like this? Where all your coordinates are then 3s. This is negative 3, 3. This is positive 3, 3. This is 3, negative 3, and negative 3, negative 3. And that might help you prove some stuff, being that all your coordinates are 3, either positive or negative. So many choices of how you can label this, just whichever way suits you best. B. Y'all try B. Position a right triangle with legs of 4 and 2 in the coordinate plane and label your vertices. So go ahead and pause and try to make one. I'm going to use the same thing, the 4 and the 2, and this is especially helpful here. I made this a right triangle. Nobody told me I had to make it a right triangle. So that right angle is very easily backed up against that perpendicular line there, and that makes this very easy. So 0, 4, 0, 0, and 2, 0. You could have put this like laying down, where this was 4, 0, and this was 0, 2. Okay, any of those methods that I showed you on that list would be fine if you didn't want to use the origin. Okay, once a figure is in a coordinate plane, you can use the slope, the coordinates of the vertices, the distance formula, which we have talked about 100 times. Maybe it's easier just to use Pythagorean theorem, or the midpoint formula to prove statements are true. Okay. Alright, so given rectangle ABCD with A at 0, 0, B at 4, 0, C at 4, 10, and D at 0, 10, prove that the diagonals bisect each other. So one of the fastest ways to prove that diagonals bisect each other is to prove that they share a midpoint. Because if they have the same midpoint, that means they have the same middle and they're cutting each other in half. Okay, so you can remember midpoint formula from chapter 1, where if you just stack, if you just stack the coordinates on top of each other and you can add them up and divide by 2. So the midpoint here would be 2, 5. Okay, here, same thing for AC, 0, 0, and 4, 10, not much adding there. Divide by 2, and that is also at 2, 5. So then we can just write a quick sentence. Since the midpoints are the same, the diagonals bisect each other. Now this is a coordinate proof. It's not the same as a traditional proof. Most of the work, most of the hard part was just me doing the work. I didn't have to justify, I didn't have to have theorems, and then instead of one final sentence, I just wrote an explanation of what I did. So that's a coordinate proof. Okay, a coordinate proof can also be used to prove that a certain relationship is always true. You can prove that a statement is true for all right triangles without knowing the side lengths. To do this, you assign variables as the coordinates. So what that's saying is on this one, I proved that the diagonals bisected each other, but that would only work for this particular rectangle with these 4 points because I was so specific. But if I do it with, instead of numbers, if I do it with variables, then that means I can plug in any numbers I want to. So that would mean that the relationship would always be true and not just in one specific case. So it's no different working with variables. You just have to just don't freak out about it. Okay, so position a figure in the coordinate plane with the given coordinates. A rectangle with a width of A and a length that's twice the width. Okay, so I'm going to do that same trick where I use the origin. Okay, a width of A, so I'm going to come over here, and if this is A long, then this point would be 0A. If the length is supposed to be twice the width and the width is A, then that means that would be 2A. So this point would be 2A, 0. And then this last point over here would be 2A, A. So same concept, same strategies, only now instead of putting 6 and 4 or 3 and whatever, I just, I use variables instead. Okay, y'all try B. A right triangle with a length of S and T, so we could do that same right triangle that we did before, but instead of 2 and 4, I can say that this is F0, 0, 0, and 0T. This isn't the only way that you can do this, so if you did a different way, then that doesn't necessarily mean you're wrong. This is just the easiest, most traditional way. All right, see you tomorrow.